So this concept here has to do with what we call a co-function identity. So let me go ahead and do a sketch of a right triangle. And they say the cosine from angle x, which cosine, in case you forget, we can go to our program. We'll press up to wrap around to the lower part of the alphabet. And we'll go ahead to trig, which is at the very bottom. And there we have SOHCAHTOA. Cosine is adjacent over hypotenuse. So we're going to say adjacent from the x is 5. Hypotenuse is 13. Now, I'll show you how this plays out, but we do have a Pythagorean triple on our hand, which is a very common one. The most common ones that I would recommend memorizing are 3, 4, 5, 6, 8, 10, and 5, 12, 13. That way, if you ever see two of the three sides in a right triangle, you just know the third one by memory, so it's 12. However, you could go to our program, Pythag, which if you press alpha 8, we get to the p's, go down 1, and then we'll go in more specifically. In this case, we were trying to find the leg, so that first option. We knew one of the legs was 5, we knew the hypotenuse was 13, and we confirmed that the other leg was 12. Now, they want the sine of 90 minus x. Well, the idea there is if this is 90, which it is because they said a right triangle, to add up to 180, don't these other two have to add up to 90? And we have that listed here on the back side of page 34 of our math reference document, which is side 4. Notice the corollary to triangle sum theorem says, not only do all three angles in a triangle add up to 180, but if one of them is 90, then the other two add up to 90. So we know that this angle, let's call it y, and x have to add up to 90. So what's 90 minus x? Isn't that just this angle right here, since they add up to 90? So from this angle, what's sine? Well, remember, if we go back to our program, sine is just opposite over hypotenuse, and opposite over hypotenuse gives us 5/13. Well, so you would just type in 5/13, call it a day. But you might be wondering, why is it the same thing? Well, that's what we call the cofunction identity. The sine from any angle is equal to the cosine of its complement, or vice versa. Cosine of any angle is equal to the sine of its complement. So that's a good thing to be aware of. And if you recognize that right away, you save the time of doing this whole process of actually drawing the triangle and looking at the relationships. And you just say, oh, I know those two things are equivalent. The answer is 5/13.